Hi, welcome to Tom Science. Today's topic is about effect of imperfect intercooler on gas turbine engine. In last lecture, we have discussed about what is meant by perfect and imperfect intercooler. Also, we have arrived the expression for intermediate pressure. Many of us would be having the doubt how to find out either it is perfect intercooler or imperfect intercooler in a given question. It is very simple. We have to remember two things. One is the outlet temperature of the intercooler. If it is mentioned, we know very well if it is equal to the inlet temperature of the intercooler, then it is called perfect intercooler. If outlet temperature of the intercooler is not equal to the inlet temperature of the compressor, then it is called imperfect intercooler if they are given temperature. In some case, they would be giving the efficiency or effectiveness of the intercooler. We know that if it is efficiency, that would be less than 100%. If it is effectiveness, that would be less than 1. In this lecture, we will discuss what is the effect of imperfect intercooler on gas turbine engine. For that, I have taken two problems. The problem number one is a gas turbine plant consists of two-stage compressor with perfect intercooler and a single-stage turbine. If the plant works between temperature limits, that is ambient temperature and maximum temperature after combustion, 30 degrees Celsius and 787 degrees Celsius, and pressure limits of 1 bar and 6 bar, that is before first stage compression and after second stage compression. Find net power of the plant. Here we are not going to find out net power, we are going to find out what is the effect, that's it. The second problem is same problem, 100%, no change at all. Only one change. Consider the efficiency of the intercooler is 80%. So in this problem, they didn't mention the outlet temperature of the intercooler. Simply they have mentioned the efficiency of the intercooler, that is 80%. This problem we have already solved from previous lecture. So if you have any doubt how to solve, kindly go through it. We are not going to solve this problem. We are going to only concentrate imperfect intercooler problem. So for that problem, we know that T1 is given in question, P4 divided by P1 is equal to 6, they given in question. T3 they mentioned perfect intercooler, so we have taken this is equal to inlet temperature 30 degrees Celsius. T5 they have mentioned, we found out P2 by assuming it is a perfect intercooler, 2.45 bar. We are not assuming, sorry, they given in question that perfect intercooler. Then from isentropic relation we found out T2. From first stage compressor work we found out. From second stage compressor isentropic relation we found out T4, and similarly second stage compressor work, and finally total work comes out by the compressor, that is 177.7 kilojoule per kg. Now we will solve the problem of imperfect intercooler. So we know that they have given the efficiency. That efficiency we can take as a effectiveness at 0.8. So that is, now we need to find out what is the outlet temperature of the intercooler by using the given effectiveness. So already we know T2, that is found out by using the isentropic relation in the compressor. That is T2 divided by T1 is equal to P2 divided by P1 whole power gamma minus 1 divided by gamma. This P2 we arrived from perfect intercooler equation, that is derived in last class. That is T2 is equal to 391.4 Kelvin. So you know already 33 for perfect intercooler, that is 30 degrees Celsius, 303 Kelvin. Now substitute, we will get it. Effectiveness is 0.8, that is efficiency is equal to 391.4 minus T3 dash. We have taken the outlet temperature of the intercooler when it is imperfect intercooler. If it is perfect intercooler, we have taken T3. Imperfect intercooler, we have taken T3 dash. So we are going to use T2 dash, T3 dash for imperfect intercooler. So T3 becomes 320.68 Kelvin. So you can see here, if it is perfect intercooler, 303 Kelvin, that is 30 degrees Celsius. If it is imperfect intercooler, the temperature is higher. For this one, we need to find out what is temperature ratio. Already we told that the pressure ratio is depends upon temperature ratio. So TR is equal to T3 divided by T1. So T3 we have 320 and T1 we have 303. That is given in question. So TR becomes 1.06. So already we discussed in last class, the TR plays major role in intermediate pressure. For this TR, we need to find out what is the actual intermediate pressure when the intercooler acts as the imperfect intercooler. If it is perfect intercooler, it is 2.45 bar. When it is imperfect intercooler, we have to use relation which is derived in the last class. That is root of efficiency of first compressor divided by efficiency of second compressor. Both are equal. We are taking 100%, getting cancelled. TR is 1.06. We know gamma value 1.4. P1, P4 we know. P1 1 bar, P4 6 bar. So this equation can be written as root of TR power gamma minus 1 divided by gamma into P1 into P4. So P2 becomes 2.47 bar. So you can check it up, the difference. When it is imperfect intercooler, your pressure ratio increases in first stage. For this P2, we need to find out what is the temperature rise in first compressor. From isentropic relation, T2 dash divided by T1 is equal to P2 divided by P1 whole power gamma minus 1 divided by gamma. Here P2 is your 2.47 bar. We are not taking P2 dash, remember that. So from this we can find out our T2 dash becomes 392.32 Kelvin. See, without intercooler itself, that is imperfect intercooler. This, see the T2 dash, here we have 391.4 Kelvin, here we are having 392.32 Kelvin. For this we need to find out what is the work given to the compressor. That is 89.77 kilojoule per kg, whereas in this case we have 88.85 kilojoule per kg. 1 kilojoule is increased, but we have intercooler, imperfect intercooler, that affects only the second stage compressor only. Now we will find out what is our T4 in the second stage. From isentropic relation, T4 divided by T3 dash is equal to P4 divided by P3 whole power gamma minus 1 divided by gamma. This P3 is nothing but P2. We know that constant pressure maintains. So our T4 becomes 413.24 Kelvin. And remember here, what is our T4? 391.4 Kelvin. So when it is imperfect intercooler, the temperature of second compressor is higher. How much? Almost it's going for a 20 something. Clear? For this, if we find out the work given to the second stage compressor, that is Cp T4 minus T3 dash, work given to the second compressor is 93.02 kilojoule per kg. Whereas here again 88.85 kilojoule per kg. And total work given to the compressor when it is imperfect intercooler, WC is equal to 182.79 kilojoule per kg. When it is perfect intercooler, 177.7 kilojoule per kg. From this we have to conclude one thing: if it is imperfect intercooler, it will consume more power compared to the perfect intercooler. When it consumes more power, W unit automatically will decrease. When W unit will decrease, automatically efficiency will come down. In next class, we will discuss what is the effect of reheater on gas turbine engine, how to derive efficiency expression. Thank you.